2 years of silent travel through the emptiness of space, and at last, NASA's OSIRIS-REx has reached its destination, a small dark asteroid called Bennu. You may not have heard much about this mission. Unlike the InSight lander on Mars, OSIRIS-REx didn't dominate headlines, but perhaps that makes this moment even more fascinating because what lies ahead could reveal secrets from the dawn of our solar system. So what is OSIRIS-REx doing here? Why Bennu, of all places? And what can a half-kilometer wide rock drifting through space possibly teach us together? Let's unravel the story of this mission, its goals and why it matters. Not only for scientists, but for anyone who has ever wondered where we came from. OSIRIS-REx is no ordinary spacecraft. It is part of NASA's New Frontiers program, alongside missions like Juno and New Horizons high-profile missions that changed how we see the solar system. Launched in September 2016, OSIRIS-REx spent over 2 years carefully navigating toward Bennu, finally arriving in December 2018. But why so long if Bennu is considered a near-Earth asteroid? The truth lies in its tilted orbit and extremely weak gravity. Unlike Mars or the Moon, Bennu doesn't offer much gravitational pull to slow a spacecraft down. OSIRIS-REx had to brake gently inch by inch, or it would have overshot its target completely. When you think about it, the spacecraft's journey was like trying to park a car on a hill of sand, without brakes, slow, precise, and unforgiving. That patience has paid off. Now, for the first time, we're seeing Bennu up close. Long before OSIRIS-REx ever launched, scientists already had a pretty good idea of what Bennu looked like. Using radar data collected from Earth, they built detailed simulations of its shape and surface. As the spacecraft approached and sent back its first images, the team compared them to their models. To their astonishment, the predictions were almost perfect. When OSIRIS-REx closed in to just 20 kilometers, Bennu came into full view, a dark, rugged world covered in rocky debris. Imagine looking down on a giant pile of rubble floating in space, and you'll get the picture. It resembled Itokawa, another asteroid visited earlier by Japan's Hayabusa mission, more a clump of fragments than a solid body. Bennu is small, only about 500 meters across, shaped like a spinning top. Its rapid rotation and weak gravity may have forced loose material toward its equator, giving it that unusual profile. Classified as a carbonaceous B-type asteroid, Bennu is among the rarer kinds, possibly born from collisions involving much larger bodies like Pallas or Polana. There's something else about Bennu, its orbit. Through countless gravitational nudges and subtle forces, like sunlight pushing against its surface, Bennu has drifted closer to Earth's path. Today, it's one of the most closely watched near-Earth asteroids. While the risk is remote, a 1 in 2,700 chance, in the late 2100s, it is still high enough to keep scientists' eyes on it. Looking at Bennu is like looking at a survivor from the solar system's earliest days, but also at a rock that one day could cross paths with Earth. And that dual identity, ancient relic, and potential threat makes it the perfect target for OSIRIS-REx. Before OSIRIS-REx could embrace its tiny partner, it had to make sure the space around Bennu was safe. Were there moons, loose debris, even a pebble could have spelled disaster. So the spacecraft traced cautious arcs around the asteroid, gradually mapping its gravitational field and scouting the environment. Once safe orbits were confirmed, OSIRIS-REx settled into position just 1.4 kilometers above Bennu's surface. To put that in perspective, that's closer than many airliners fly above the Earth's ground. Never before had a spacecraft orbited such a small body. From this perch, OSIRIS-REx began surveying Bennu in exquisite detail. Cameras and instruments scanned for variations in minerals, temperature, and texture across the asteroid's face. Every rock, every slope, every pocket of dust mattered. Why? Because hidden somewhere in that landscape was the perfect place to attempt something no NASA mission had done before: collect a piece of an asteroid and bring it home. For the next year, Bennu would be studied from every angle, its surface charted like a world map. This wasn't just exploration. It was reconnaissance for a high-stakes moment yet to come. Most spacecraft never return what they touch, but OSIRIS-REx was built for a single delicate purpose: to take a piece of Bennu and bring it back to Earth. In mid-2020, the spacecraft would attempt its first sample collection. The process was nothing like a landing. Instead, OSIRIS-REx would drift down at a snail's pace so slowly it almost seemed to hover. Thrusters were kept to a minimum. Firing them near the surface could blow away or contaminate the very particles scientists wanted. As the spacecraft descended, its solar panels folded into a Y shape, both to avoid touching the ground and to protect them from dust. At the heart of the maneuver was a robotic arm tipped with a round sampling head. At the moment of contact, a sudden puff of nitrogen gas blasted the surface, stirring up particles and fragments no bigger than a pebble. These fragments shot into the sampling chamber, which sealed shut within seconds. It was over almost as soon as it began. Scientists hoped for at least 60 grams of material, just a handful of dust, but enough to unlock immense secrets. To measure the sample's weight, OSIRIS-REx would spin itself in space, comparing its inertia before and after. If the sample was too small, the spacecraft could try again. Once secured, the sample container would be tucked safely into the return capsule. Then came the wait. In 2023, that capsule would streak through Earth's atmosphere and land in the Utah desert. Scientists would be waiting ready to carry a piece of Bennu into laboratories on Earth. You might ask, why all this effort for a rock just half a kilometre wide? The answer lies in what asteroids really are. They are time capsules, remnants from the birth of the solar system 4.5 billion years ago. While planets like Earth, Mars and Venus have been reshaped by volcanism, weather and plate tectonics, asteroids have remained largely untouched. Inside them lie the original ingredients from which worlds were built. Studying those ingredients is like reading the recipe of creation. Even more compelling asteroids like Bennu often contain carbon-rich compounds, water-bearing minerals, and even amino acids, the building blocks of life itself. Did asteroids seed Earth with the materials needed for life? It's possible. Bringing back an uncontaminated sample gives us a chance to test these ideas directly, free from Earth's influence. Every grain of Bennu's dust could carry clues about how planets formed, how water arrived on Earth, and maybe even how life's chemistry began. When we hold that sample in our hands, we'll be holding history older than Earth itself. Bennu may be small, but it carries within it a story as grand as the cosmos. OSIRIS-REx is more than a mission of exploration. It is a bridge to our origins and a reminder that even the tiniest rocks in space can shape our future. If successful, OSIRIS-REx will return a priceless gift, evidence that could change how we see ourselves in the universe. For now, the spacecraft continues its silent dance, with Bennu carrying the hopes of all who seek to understand where we came from. As we wait for that sample to arrive back on Earth, let's remember, space is not just a place we observe. It is a story we are still writing, one mission at a time. And perhaps next time you look up at the night sky, you'll wonder not just what's out there, but how much of it is already a part of you. We've travelled across millions of kilometres to meet Bennu, a relic from the dawn of time. OSIRIS-REx is more than just a spacecraft. It's our messenger carrying pieces of the past back to Earth. What it discovers may one day reshape how we understand life itself. If you enjoyed this journey, let's keep exploring together. Subscribe to Cosmic Compass so you won't miss our next step through the universe. Until then, keep looking up, keep wondering, and remember, the cosmos is not just out there, it is also within us.